Speaking of cool solutions around things that could be a disaster, it's my pleasure to introduce you to Evan, who is one of the co-founders of Switch. And when we're talking about utilities and energy, what does blockchain have to do with that? I don't know, but he certainly does. So, Evan.
Thank you.
And I guess you have a last name too.
Yeah, I have a last name as well. Yeah, I just go by Evan, so. So I don't have a slide deck to go through because it's typically not how I roll. So I'm Evan. My background has been in energy trading for the last 15 years. My main focus was kind of what all kids wanted to do in the early 2000s, was go and be in finance. And so I kind of picked the most challenging marketplace that I thought existed in finance, which was commodities trading. And this was post-Enron. So that was my life for 15 years on Wall Street. As I started understanding the energy markets more thoroughly and started seeing the rapid adoption of renewable energy in the US, I realized my business was quickly going to zero in terms of the way that energy trading existed wasn't going to exist the same as it had in the past. And I left Wall Street and I started working with private equity groups and went from trading to project finance and building wind farms, distributed energy resources, and really trying to understand the mechanics around how do you develop renewable energy resources, how do you develop the right types of resources in the right types of places, and fully focusing on the greening of the electricity grid. It's not just a domestic problem, it's a global issue. And so about a year ago, we kind of linked up with some partners here. My main focus was all renewables, and about a year ago, linked up with my co-founder, John Clippinger, who's at the MIT Media Lab. He was at the City Sciences, he's now at the City Sciences group, but he was in the Human Dynamics group, and that was really my first interaction with blockchain. And at the time, we started doing a lot of research and talking to all the partners that we had when we first, not we, but throughout my entire career, worked with. So we're talking about energy developers, we're talking about power plant managers, we're talking about private equity groups, and the overwhelming response was they have a desire and a need to deploy resources in the renewable energy space, but they had a significant amount of fragmentation and friction in order to do it, and not just from an investment perspective, but regulatory, and the need was there. And over the last 2 or 3 years, Silicon Valley technology companies have been extremely forward-thinking in terms of having stated corporate sustainability goals and renewable standards. And that's not just from them, it's from cities globally, and huge communities of cities and municipalities have stated stated sustainability goals, and it's impossible for them to actually achieve them. And so we started exploring, identifying, using blockchain and something called the Dynamic Adaptive Control Module, which is a fancy way for saying a kind of a dynamic oracle, to create the right types of incentives to accelerate the adoption of renewable energy in spaces that need them the most. And so if you look at the world, the developing world, obviously one of the main issues is energization, but at the same time, the communities that have very little access to energy also have very little access to clean energy. And so they're the ones who are burning diesel fuel, bunker fuel, some of the most pollutive fuel resources, because they happen to be some of the oldest technology, but also fairly easy in terms of logistics to get through. You can store a barrel of oil, there's significant amount of resources, infrastructure to get fuel to power plants. But if you look at the last 2 years, the cost of solar and batteries has dropped to the point where one researcher calls it the God parity, which is a generation on demand. And something that I want to talk about is that the cost of generating solar in most places of the world that actually have solar resources plus batteries is cheaper than the delivery charge for most regulated markets. And so if you look at your electricity bill in most markets that have centralized dispatch, there's 2 parts of your bill. You have your supply ply, and then you have your delivery charge. And so we're talking about rapid acceleration and cost curves that make it cheaper to self-distribute. And so you're seeing a lot of blockchain projects now that are trying to build infrastructure to enable peer-to-peer trading of something called a transactive energy. And transactive energy is something that's super exciting to me, and probably would put this room to sleep. This is what I did for 15 years, is traded and optimized energy resources from power plants and basically just arbitraged inefficiencies in grids. And transactive energy specifically is something that is going to rapidly change how utilities look at energy specifically, and it's rapidly changing their business models. And we've had dozens of conversations with large utilities in the United States and also globally around how they're going to be transitioning from a traditional centralized utility to more of what they're calling a DSO and a platform. And so DSO is a decentralized or distributed systems operator, and their blockchain is actually enabling, or these pilots that they're doing now are enabling communities to understand a bit more about the data. And something that is really important is that interval data is not enough. So right now, in most markets, 15 minutes interval data is not enough to be able to manage either a nanogrid or a microgrid. And in order for the world to get to what everybody's kind of stated is 100% sustainable and renewable, you have to have an incredible amount of data and incentives for sharing data in order to get the right types of resource management. And so whether you have a smart thermostat or a smart refrigerator, if you have a power wall or a battery installed in a rooftop solar system, you need data, you need a significant amount of information to identify how resources will be optimized in a local grid, and a nanogrid, which is inside your home, a microgrid, and then a local grid. And so all of those kind of resources are helping the grid to be able to accept what they call distributed energy resources, which are these small rooftop solar systems, community solar systems. Without the underlying infrastructure for technology, it would be very challenging to be able to disrupt how traditional utilities track and trace and store and bill for energy specifically. So my company is actually a nonprofit foundation that's building protocols to help track and trace and verify both renewable energy from a distributed basis as well as kind of more of a large-scale commercial basis, and allow for basically a global incentive mechanism to help accelerate the adoption of renewable and sustainable energy using incentives. And one of the key things we're working on is something called mechanism design, where it's a dynamic open source oracle that shares data, that values renewable energy data specifically the most, and then creates dynamic incentives in the form of a token that communities, whether it's cities specifically, whether it's states, can actually create their own types of local incentives to incentivize certain behavior. And so if you look at City of Austin, for example, a lot of these incentives are siloed, right? Whether you're looking at LED lighting or more efficient, the rebates for LED lighting, or more efficient, basically hardware or kind of building design or LEED certification. Those programs are fairly balkanized, and that doesn't really tie into the state programs for renewable energy credits, also local tax incentives, et cetera. So you have a bunch of these programs that exist. There's a massive desire and need for these types of incentives. And I mean, if you think about trillions of dollars have been spent already, and we only have like 5% of our total installed capacity is renewable energy. And so, we're talking about climate change here is a pretty big deal. Carbon is also a really big deal. And coal is, hopefully there's no one from Pennsylvania in here, but coal is pretty bad. And so, from my perspective, blockchain actually allows for, and our goal is to create the protocols via blockchain to be able to help dynamically value renewable energy adoption globally. And so, I think when you look at carbon in the United States or carbon in a local market, the impact is global. And so you have local pollution issues, but carbon is a global problem, and you can't solve the problem here at home if you're not willing to solve the problem globally as well. So you need to have a global community that's able to organize around renewable energy and really focus on something that's kind of, I would say, low-hanging fruit in some ways because of the way that costs have come down, and really kind of move to a much more sustainable way of thinking around energy specifically, and move away from linear thinking around economies of energy, which is, take, make, and throw away, and that's kind of our process now. And so we can drive cost of energy to zero, the marginal cost of energy to zero over the next 10 or 15 years, maybe even earlier. And then, what kind of benefits can we get from free power? So, thank you.